In this lecture, I am going to introduce you to ANSYS DesignModeler. So inside ANSYS Workbench, we have two types of geometric systems. One is the DesignModeler geometric system, and the second one is the space claim geometric system. And if you want to create simple components and you want to edit whatever the data that has been imported from other CAD systems, you can efficiently use this geometric modeler or design modeler. Then if you want to create advanced parts and advanced assemblies, then you may use the space claim design modeler. In this particular course, I am going to introduce you to design modeler basics. So in order to access design modeler, you need to first select this particular design component. So what I am going to go to is the geometry component, and then I am going to drag the geometric component and place it on the project schematic. And once I place it on the project schematic, what I am going to do is I am going to right click on this cell, and here I have option to select the two types of geometric modelers as I have mentioned before. As we are going to deal with the design modeler, I am going to select new design modeler geometry. So once I selected the new design modeler geometry, this particular ANSYS Workbench will open the design modeler module. And once the geometry module has opened, we have, as in any other CAD system or CAD software, we have three planes: XY plane, ZX plane and the YZ plane. These three planes correspond to the three planes, namely the top plane, side plane as well as the front plane in any design software. So here the first and foremost thing is we need to create some primitive shapes like say square, sphere and such sort of objects. So in order to create such sort of objects, you need to go to create, and in the create you can select primitives, and from here you can select from many different shapes that are available by default. So for this purpose, what I am going to do is I am going to select the sphere option. So once I select the sphere option, see here the sphere has been populated in the tree outline menu, and the details of this particular sphere are appearing in the details view window or details view component of the total design module. So here the first and foremost thing is I need to give the origin for the sphere. So let us say the origin of the sphere is existing at 0 in the x-axis, 0 at the y-axis and 0 in the z-axis. Then the next thing is I need to specify the radius of this particular sphere. See here the units, if you observe, the units are in meters, so I need to enter the values in meters here. So I am going to enter 5 meters instead of 1 meter. I am going to enter 5 meters. So I have given this particular radius of the sphere. So in order to generate or in order to create the shape, you need to right click on the sphere and then press generate and then click on generate, so that the body is going to be generated. See here we have created a solid body, but I don't want a solid body, I want a simple hollow body. Then what can I do? I am going to go again to create and go to primitives once again, and I am going to just select box here instead of sphere, and I am going to denote that the origin of the box or the square is at the exact same location where the center point of this particular sphere has been presented or has been created. Then you can see you are going to give the diagonal length. So in the x-axis it is 5 meters instead of 1 meter, in the y-axis also it is 5 meters, and in the z-axis also it is a 5 meters. So every side is equal, so we can call it as a square. Now what I want to do is I want to create, instead of creating a solid body, I want to create a hollow body. So if you want to create a hollow body, you have an option known as thin surface. So in this particular option you can click here and you can press S. So if you have selected the S as this particular option, then you need to give the thickness. So you can give thickness in two directions. One is the inner direction and other one is the outer direction. So inner direction means, suppose if you take this as the surface of the body, if you specify the inner thickness, what happens? The surface will be extruded towards the inner side of this particular body, and likewise if you give the outer thickness, it is going to be extruded to the outside of the body, and remaining material will be removed from this object, making it as a hollow object. And once I have selected all the required options, I am going to just generate and create the body. So here there is a square, thin square that has been generated inside the body. Then if you want to delete any of these bodies, what you can do is you just right click on any of the body from the tree outline menu and you can just select delete and then press yes. You have deleted the created body. Then coming to the sphere, just right click on the sphere and just delete the sphere. Likewise, you can go to create and you can go to primitives option and you can select number of options that are pre-existing inside ANSYS Workbench. You can create a cylinder, you can create a cone, you can create a prism and other sorts of things. So this is how we can create some primitive shapes using Geometric Modeler or DesignModeler. In the next lecture, we are going to use the sketching options as well as the modeling options that are present inside Geometric Modeler. In this lecture, I am going to show you how you can make a DesignModeler as your default geometric system, and then we are going to create some basic shapes using the sketching as well as modeling tools present inside DesignModeler. For that purpose, I am going to go to the component systems once again, going to drag this geometry component system and place it on the project schematic. Now what I need to do is, one thing is I need to go to the tools and go to options. So in the options there is a option known as the geometric system. Here there is a geometric system, so you just select this geometric import, and in this geometric import you can select this preferred geometric editor. From this you can select our preferred geometric editor to be DesignModeler instead of Space Claim Modeler. So once you have selected this one, you can just press OK. So now once you have selected that particular option in the tools, you right click on this geometry cell. You see now instead of showing Space Claim Geometry Modeler on the top, it is showing DesignModeler on the top. So now what I am going to do is I am going to just select DesignModeler so that the ANSYS Workbench will open DesignModeler module. And the foremost thing you need to do once you open this DesignModeler is you need to set the units. So right now if you see the ruler here, you can see the units are in meters. Then you go to the units option here, and I want to change my units from meter to millimeter, so I am going to select millimeter here. So once I select millimeter, as usual in any CAD system, we need to select a plane and we need to create a sketch on that plane, and then we need to apply the modeling options such as say extrude cut and other such a type of options. This is the same procedure that is followed here in DesignModeler as well. So for this purpose, I am going to select the XY plane, or let us say I am going to select ZX plane, which will be my top plane. Then I am going to switch to the sketching tab. So in this sketching tab, you will have access to all the 2D sketching tools that are present inside DesignModeler. Like see, in the draw group, you will have access to line, tangential line, polygon, rectangle and other sorts of 2D sketching entities. And then in the modify group, you will have access to all the modification commands which are used to modify 2D sketches. Then you come across dimensions, then geometric constraints and settings as well. So what I'm going to do is I'm going to go to the draw group and I'm going to select rectangle, and I'm going to select one starting point here and an ending point of the rectangle here, so that a rectangle is created in DesignModeler. Now what I need to do is I need to dimension this particular rectangle. So in order to dimension this particular rectangle, I need to switch to dimensions group. So I have switched to dimensions group. In the dimensions group, see, I always opt to use this general dimensions tool, so that this is the one tool that can be used to create any type of dimension. It may be a linear dimension, it may be angular dimension, it may be a radius, or whatever the type of dimension. You can use this single tool in order to create many types of dimensions. So I generally prefer to use this general dimension. So I've selected this particular tool, and then I'm going to select this particular line, and I'm going to select this particular line. And if you see, first of all, I've dimensioned this line and it has been indicated as H1, and this is V2. So H means it is representing that this line is horizontal, and V means this line is vertical. Then 1 means, so in both of the dimensions, I have created this dimension first and I have created this dimension second. So whenever you create the dimensions, it is going to place this type of alphabets as well as this type of numbers, showing type of entity it is and the number is in which order you have dimensioned. So once you have selected you have dimensioned these two lines, see here in the details view you will have this h1 as well as v1 represented here. So from here you can just edit the dimensions. Let us say the dimensions are 50 mm by 50 mm. So I've created the dimensions. Now what I need to do is I need to exit the sketching mode and go into the modeling module. So for that purpose I just need to switch from sketching mode to modeling tab. And once I switch from sketching mode to modeling module, here you have the options like extrude, revolve, sweep, skin or loft and etc. So I'm going to use the extrude option. So once I select the extrude option, here in the details view it will ask you what is the geometry for which you want to apply the extrusion option. So I need to select the sketch from this tree outline. So previously I have created the sketch on the ZX plane. I'm going to expand this ZX plane and I'm going to select this sketch 1 and then select apply. And once I select apply, you need to give the depth of extrusion, whether it is 30 mm, 50 mm, 20 mm, 30 mm. So I will leave it to default. If you want to change, you can just click on here and you just enter whatever value you require. And once you have entered the value, you need to just right click on this particular feature and say generate. So once you generate the feature only, it will be applied. Then this is how you can do extrusions. So if you want to cut a hole in this particular part, then you need to go to hole and you create a hole here or circle here, and you need to extrude cut this particular material. So as like in other geometry softwares, you cannot directly select this face and create the circle for the hole. What you need to do is, first of all, you need to create a plane on this surface, and once you create the plane on this surface, then only you will be able to draw the sketch and you can apply the extrusion cut option. So for that purpose, what I'm going to do is I'm going to go and create a new plane. So I have selected to create a new plane, and the plane name is plane number 4, or you can just select this one and rename like my plane. Whatever name you can give, no problem. And it is asking us what is the base plane. So in order to create a new plane, we should give some references. So here what I'm going to do is I want to say create a plane on this particular face. So I'm going to select, instead of from plane in the type, I'm going to select from face. Instead of from plane, I'm going to select from face. So once I've selected this from face, then it is asking me which face is going to be reference face for my new plane. So I need to select this from this particular geometry. So what I need to do is I need to select here I need to select this particular option, and then again I need to select this particular face and say apply. So now you can see there is a new plane known as the my plane has been created on this particular surface or face of this particular object. So I'm going to right click and say generate. So once I have generated this particular plane, I'm going to select this plane and I'm going to go into the sketching mode, and I'm going to select the circle, and once I select the circle, I can draw the circle on this particular face. So then again I come back into modeling tab and I am going to select the extrude. So it is asking me once again, it is asking me what is the sketch entity for which you want to apply this extrusion option. So I'm going to expand this my plane, then I'm going to select the sketch number 2 and press apply here. So once I have selected this particular sketch 2, it is showing me a preview. See, if you are going to add material, it is going to be added in this particular direction and the object will look like somewhat like this. So instead of using that add material here in the operation, I can choose to cut material because I want to remove the material. So I have chosen to cut material, and see what happens. The direction has been reversed automatically because we are going to remove material. So once I have specified the direction and cut material option, now what can I do is I need to specify the depth of cut. So as this is a 30 mm block, I can leave this 30 mm to default. Then I can right click and say generate in order to create the hole. So this is how you can use the same option to extrude or add material to a sketch and as well as remove material from an object. So likewise you can have revolve option, sweep option, skin option, loft option, etc. So in the next lecture we are going to see how to use the revolve, sweep and the skin loft option in DesignModeler of ANSYS. Thank you. In this lecture we are going to see how to use the revolve, sweep and skin and loft options inside DesignModeler. So here, if you have observed, I have created this particular body in the last lecture. So I want to clear off this particular body. One thing you can do is you can just right click on this particular operation or the feature. You can just press delete so that you can delete this particular operation, and then you need to delete this operation, and then you need to delete this particular sketch, and you need to delete this particular sketch in order to clear off the total geometry that you have created previously. But there is one another option. If you want to start afresh, then you need to go to the file, and there is an option known as start over C. It can also be accessed by the shortcut keys of Ctrl+N. So if I just select start over, and I'm going to, it is showing me an warning that if you are going to proceed forward, this total model will be cleared and you will be starting afresh. So I'm going to select S. So once I have selected this one, I'm starting afresh. See, whatever the sketches we have created earlier and whatever the features we have applied, all of them were cleared away, and even the planes we have created, they also have been cleared. The total geometric modeler has been reset. So here I'm going to show you how we can use the revolve option. So first of all, what I'm going to do is I'm going to XY plane, which will become the front plane for me, and then I'm going to sketch tab, and then I'm going to say draw a arbitrary rectangle. I'm not going to give any dimensions to this particular rectangle, and once I'm satisfied with this particular rectangle, I'm going to switch to the modeling tab. In the modeling tab, I'm going to select the revolve option. So once I select the revolve option, here I need to select two entities. One entity is the cross section which I want to revolve, and other one is the axis about which I want to revolve the selected cross section. So for the cross section, I'm going to select this particular rectangle, so I can access this particular rectangle by say expanding this XY plane and by selecting this sketch 1, and now I am applying this, and then in order to select axis, you need to select from this particular design space or graphics window. I'm going to select this particular axis, and I'm going to press apply. Then the operation is by default to add material, and if I want to rotate it, revolve it through 360 degrees, it will be a complete cylinder with a central hole, or otherwise I can also give the angle. So I want to just revolve this object through 180 degrees only. So see here what happens, only half of the revolving or half of the revolving has occurred. Now what I want to do is I want to reverse the direction of revolving. So for that purpose, I am going to go to the direction option here. I'm going to select reverse. So this particular option is present in all the options such as extrusion, revolve, sweep and skin or loft. So if you want to reverse the direction of the application of the feature, you can just select this reversed option from the direction option which is present here. So once you have reversed this particular direction of revolving, you can go, and if you want a thin surface, you can just select here S, and you can give the thickness. So invert thickness, I have given the invert thickness as 1 mm, and once I have done all these things, I can just right click and say generate. Now see what happens is, instead of a solid body being created, what happens, because I have selected the thin surface option, a hollow body with the given thickness has been created. So this is how you can use the revolve option. Likewise, you can also create a body, and then you can say remove material from the body using this revolve option. Now what I'm going to do is I'm going to press Ctrl N so that I'm going to start afresh, showing you how to use this sweep option. So I'm going to press yes. So once I have selected this one, I'm going to select the XY plane first, and then I will switch to sketching mode, and then I'm going to draw a simple rectangle. And once I draw the simple rectangle, then I need to select another plane on which I am going to create a path through which this particular rectangle will be swept. So I'm going to select the ZX plane, and then I'm going back to sketching mode once again. I'm going to select the line, and I'm going to create some line arbitrary length. It is of arbitrary length. And once I have finished this one, I'm going to switch to the modeling tab, and once I've switched to the modeling tab, I am going to go and select the sweep option here. So once I select the sweep option, so it is showing profile object must contain at least one chain. Don't worry, you don't need to worry about that particular warning. See here, for the profile, I am going to select this particular rectangle which I have drawn on the XY plane. So I am going to select this one and press apply. And once I applied this one, for the path, I am going to select this particular sketch which I have created on the ZX plane. So I have selected this particular sketch and I am going to apply. And all other options I am going to leave it to default, and I am going to right click on the sweep and going to generate. So once I generated, see, the sweep option has been applied. You can either creating a sweep for a straight line, you can use a spline to create pipes of different shapes and different bends. There you can use effectively the sweep. For just creating such sort of objects like this, you can simply use the primitive options that are present inside DesignModeler, or otherwise you can directly use the extrusion option. But this is only to show you how we can apply this sweep option. Then I'm going to once again press Ctrl N, and I'm going to start the model once again. So I'm going to press S again. Now here I'm going to show you how we can perform skin or loft. So first of all, what I'm going to do is I'm going to select the ZX plane, which will be my top plane, and I'm going to just go to the sketching and just draw a rectangle once again. I'm going to just draw a rectangle, and once I have drawn the rectangle, what I need to do is, in order to apply the loft option, we need two parallel planes with the two parallel sketches at some distance to each other. So for that purpose, what I'm going to do is I'm going to create a new plane. So here in the type I am selecting from plane, and what is the base plane it is asking us. So I'm going to select the ZX plane. It is by default selected, so I don't need to change this one. So right now what I need to do is I need to have two parallel planes at some distance in order to apply this loft option. So here, if you come to this transform option, there is a option selected as none. Instead of that, I'm going to give some translation option here. So how can you translate? In which direction you are going to translate? So here, if you come to the global coordinate system, the x direction is in this direction, z direction is in this direction, and y direction is in the top direction. But when you come to the local coordinate system, here you see this blue color represents the z axis. So if you want a plane that is going to be parallel to this particular selected plane, you need to offset the new plane in the z direction. But if you take the reference of a global coordinate system, this direction is y direction, but local coordinate system, this is the z direction. So you need to select offset z, and in the offset z you need to give the distance of offset. So I am going to give the distance of offset as 100 mm and press enter. And once I press enter, I can see a preview clearly. And once I am satisfied with the preview, I can just right click on this option and say generate the option. And from this, what I'm going to do is I'm going to again go to the sketching mode, and I'm going to create a circle. So I have created the circle, and once I have created the circle, I come back to the modeling module and then our modeling tab. Then I'm going to select the skin or loft option. So it is asking what are the two profiles between which I need to create a loft. So the first profile I need to select is the profile which I have created on the ZX plane, which is the sketch one. So I'm going to select this one, and then again I need to expand this plane 4, and I need to select the sketch 2 as well. In order to select the multiple sketches, you need to press Ctrl. So by pressing Ctrl, you can select 2 or more number of sketches. So once you have selected all the profiles, you can say apply, and it is asking, okay, there is a simple warning that is showing that the profile, whatever the profile sketches we are going to use, they should be having equal number of edges. I will try to generate, but there is an error. So what I'm going to do is I'm going to delete this particular option by right clicking on it, and I'm going to delete this option, and then I'm going to delete this sketch 2 as well by right clicking on it, and then what I'm going to do is I'm going to go back into the sketching mode once again. Instead of a circle, I'm going to draw another rectangle, so that what happens, both the profile have same number of edges, so a loft can be created very easily. So once I've created the rectangle, I come back to the modeling tab, and in the modeling tab I am going to select this particular skin or loft, and by pressing Ctrl I am going to select these two sketches as my profile sketches, and I say apply. Now see, there is no warning that has occurred. So once you have done, and you can keep all the options same, and then I can just right click and say generate. So even though we have selected the same number of edges, we haven't successfully created a loft. See why? Because you see, the direction, this particular rectangle is in the negative direction, that particular rectangle is in the positive direction. So what you need to do is, we are going to go back to the sketch once again. We are going to delete these two sketches. So I'm going to delete this feature, and I'm going to delete this particular sketch, and then I'm going to go to the sketching tab, going to rectangle again. Now you see, I'm going to draw a rectangle on the similar side. So once I've selected, I've drawn this particular rectangle, I can go to this loft tab, and I can select both the objects by pressing Ctrl and press apply, and then I can just generate a loft. See here, a loft has been successfully generated. Through this video, I was able to show what are the common mistakes a person can do or can come across while he is creating some lofted, or he is using the lofted command. So in the next lecture, we are going to see how to create a 1D object by creating a simple bicycle frame, and we are going to learn how we can create that in the DesignModeler. Thank you. In this lecture, I am going to show you how we can create 1D objects using DesignModeler. We are going to create a simple bicycle frame for this example. So in order to start afresh, I am going to press Ctrl N. I'm going to just press Ctrl N, and I'm going to select S, so that I am going to start over. So in order to create 1D objects, the first and foremost thing is you need points, and once you get the points, you need to join those 2 points by line. So in order to create a point, you can go and select this point option. So once you select the point option, see here, the type of point you are going to create is a construction point, and how are you going to define the coordinates of this particular point in the space? So by default, it is going to show from coordinate file, but we don't have any coordinate file right now. So what I'm going to do is, I'm going to press, and I'm going to select manual input. So if I change the option to manual input in the definition, so it will ask us the coordinates of the point. So I'm going to create my first point at the origin of the space, which is 0, 0, 0. And once I'm satisfied with this particular coordinates, I'm going to right click and say, right click and generate the point. So here, see, you have created a point at 0, 0 and 0. Now what I want to do is, I want to create another point which is at a distance of 100 mm from this starting point in the x direction. So in order to do so, what I need to do is, once again I need to select the point option, and in the definition, from instead of from coordinates file, I need to select the manual input, and in the manual input I need to change this x coordinate to 100 mm, and then keep the other 2 coordinates in the default values, which are 0, 0. Then I am going to right click and generate the point. See here, a point at a distance of 100 mm in the x direction has been created. Likewise, you can create n number of points using the point option and through manual input. Now I need to create a line between these 2 points. So in order to create a line between these 2 points, what I need to do is, I need to go to the concept, and I need to select the option called lines from points. So I have selected the lines from points, and now what I need to do is, I need to select, by pressing Ctrl, I need to select both of these particular points, and once I select both the points, see here, a green color line appears, which shows that a line has been created between these 2 points, and once I'm satisfied with that, I'm going to press apply here in the details, and then I'm going to right click on the feature here in the tree outline, and I'm going to generate the feature. So see here, a line has been added between these 2 points. But see, if you want to create a complicated object which has a number of points and which have a number of lines, so how can you do? Instead of giving all the points like this manually, it will be a very tedious task. One thing you can do is you can create what is known as a coordinate file, and once you create the coordinate file, you can just import it into DesignModeler, so that you will be able to generate the all points at once, at simply with a single step. So for now, what I'm going to do is I'm going to just delete this line by pressing delete, and then I'm going to delete this point as well, and I'm going to delete this point as well. So first of all, what you need to do is you need to create a coordinate file. In order to show you how we can create a coordinate file, I'm just going to go and show you. So here, see, for a bicycle frame I have created a points data. So you need to just open a simple say Word document, or say notepad, simple notepad, not Word document. Then you can give such type of inputs. So what is this particular column indicate is, this particular column indicates the set of points. So what happens is, for example, if you have a 2-story building, and then you are going to give the coordinate points for the first floor in one set, and you are going to give the coordinates for the second floor in the second set. That is also we are going to see in the next example itself, so you need not worry right now. And this is the point number. So this is the first point number, this is the second point number, third point number, fourth point number, and 5.678 points. So from this, what we can understand, we have a point group, one point group with 8 points, and these are the XYZ coordinates of this particular point. So what happens if I am going to select this coordinate file, what happens, the first point is going to be created at a distance of 400 mm in the X direction, and 400 mm in the Y direction, and 0 mm in the Z direction. Likewise, 8 points, if I select this coordinate file, 8 points will be generated. So I'm going to close this particular say data points data file, and I'm going to go to DesignModeler, and then I'm going to select the point option, and by default the definition of points will be from coordinate file. So now I'm not going to change this option, and in the coordinate file option, if I just click here and click here, it is asking me to browse where the coordinate file is present. So I'm going to go to the desktop, and I'm going to go to the ANSYS course files, and I'm going to go to the DesignModeler, and I'm going to select this points data bicycle frame, and I can just open it. And once I have opened it, I can just right click on this point, say generate. Now see, different points have been generated. So here different points have been generated. So all the points were not visible at first, because what happens is our scale of zooming is little bit less when compared to the scale of the geometry. For that purpose, what you can do is you can just select this option, so that you can bring the total geometry into one single frame. That is fit to screen option, that is nothing but fit to screen option. So we have this points generated from a coordinate file. So it is very easy. See, with only one point option we were able to create some 8 points. So once we have created the 8 points, now what we are going to do is we are going to go to the concept, say select the lines from points, and I'm going to select this points. So remember one thing, if every line is going to have the same type of structural element, then you can select the total lines in single say in the single phase. So for example, let us say if this particular line is made up of some square beam, and the next line which I am going to select is going to be made of circular beam, we cannot generate these two lines in a single line file. So if we have multiple cross sections, you need to select the points separately, but if you have the same cross section, you can just select it in a single group. So I'm going to select it right like this, because every line is generated using a simple circular cross section. So I'm going to select all the points in a single line file or line option, and see here, this is how we can just create all the bicycle frame. So just select this one and also select this one. No, I don't think we have this line. So what I'm going to do is I'm going to again reselect these 2 points so that the line that was applied previously will be gone, and then I'm going to select this point, and I'm going to select this point as well, and I'm going to select this point, and I'm going to select this point, and I'm going to select these 2 points, then I'm going to select this point and this point, and I'm going to select this point and this particular point and say generate. I need to apply first and then say generate. So what happens, in a single stretch we have created all the 12 lines, but if you have different lines bearing different cross sections, then you need to create different lines. So for example, if this is a rectangular cross section, you need to generate this line separately. Okay, then going to the tools, in order to apply the cross section for this particular lines, you can go to the concept, and in the concept you need to select the cross section. So this particular bicycle frame is made up of a circular tube, so I'm going to select the circular tube cross section, and here it will ask me to give the dimensions of the cross section. So here there are 2 dimensions basically. One is the RA, which is the inner radius of this particular circular tube, and RO, which is the outer radius of this particular circular tube. For this purpose, what I'm going to do is I'm going to give the inner I'm going to leave the inner radius as 10 itself, and outer radius as 12 mm. So I've created a simple cross section, and once I have created this simple cross section, I need to apply this cross section to the line. So what I need to do is I need to expand the parts body here, and I need to select this line. In this line, you see that in the details part you are going to see an option where you can apply the cross section. So I'm going to select this particular circular tube as my cross section, and then just see all the cross sections have been applied. All the cross section has been applied. Now what I can do is I can go to the view tab, and I'm going to select this cross section view or cross section solids, so that I can see what type of cross section has been applied. So this is the basics type which can be used to create 1D objects or say 3D objects that consists of trusses and frames and other sorts of structures. For example, if you want to create a bridge structure, you are going to model the bridge structure in DesignModeler using the same approach. So this is how you can create 1D objects. In the next lecture, we are going to see how we can create an hybrid model where it contains 1D objects along with the 2D surfaces also. Thank you. In this lecture, we are going to see how to create an hybrid model which consists of 1D objects as well as 2D surfaces. It is very easy. So in order to start afresh, I am going to select Ctrl N, and I am going to press S again. And now what I am going to do is I am going to create a set of points. So in order to generate that set of points, what I am going to do is I am going to go to the point option, and in the point option I am going to select the coordinate file by browsing the file location. So I am going to select the points data, 2-story stage, and then I am going to select this one, and I am going to right click and generate this particular data. See here, number of points have been created. So yeah, in order to create lines in between these points, I can go to the concepts once again, create lines. I'm going to select line. So for time being, I'm going to just create lines between these 4 points. There's 4 points only. So once I've created, I'm going to apply. So I've created lines between these 4 points. Now what I'm going to do is I'm going to go to the concept. Oh sorry, I need to generate this line. So I've right clicked on the line and say generate, and once I've generated this particular line, I need to go to the concepts once again, and I need to go to the surface from sketches. So you need to select either surface from sketches, but we haven't had any sketch, so we need to select surface from edges, and then you need to select this by pressing Ctrl. You need to select this 4 lines. so that a surface will be created between these four edges. You see, when I just right click and say generate, a surface has been created. Likewise, you can have a combination of simple 1D objects as well as 2D surfaces. So I am going to will go to the concepts once again. Say select lines from points, and I'm going to select this 2 points and this 2 points as well. So it is just to show you that this 1D objects as well as the 2D objects can coexist, and we are going to perform different analysis over on such type of objects. So I'm going to just right click and say generate the object. So instead of creating surfaces from this sort of points and lines, you can also create it from sketches. In order to create from sketches, once again what I'm going to do is I'm going to press Ctrl N, and I'm going to start over once again, and I'm going to create a rectangle. I'm going to go to the sketching mode. No, first of all I'm going to select the ZX plane, and then I'm going to go to the sketching mode. In the sketching mode, I'm going to select the rectangle, and I'm going to create a simple rectangle. You can create a whatever shape you want, but it should be a closed shape in order to generate a surface. So once you have done this, you can go to the concept. Instead of selecting surface from edges, you can select surfaces from sketches, and here you need to select this particular sketch and then press apply, and here you can give the thickness of the surface here, or otherwise you can just give the thickness of the surface there inside the mechanical also. So once you are done with the options, you can just right click and you can set generate. So this is how you can generate surfaces from the sketches. So in the next lecture, we are going to see how to import a 3D object into the geometric modeler, and also we are going to see how this 3D object can be converted into a 2D surfaces object. Thank you. Lecture, I am going to show you how we can import a 3D object into DesignModeler, and then we can convert this 3D object into a 2D object. So in order to do this, I am going to again press Ctrl N to start afresh, and I am going to press yes. And now what I am going to do is I am going to go to file, and here I have options to import. So I am going to import external geometry file. So once I selected import external geometry file, I need to browse to the file location. So I'm going to go to the desktop, and then I'm going to go to the ANSYS course files, and I'm going to go to the DesignModeler, and I'm going to select this bracket STP, and I press open. And once I have selected the file, I'm going to just right click on this particular import file and going to generate it, so that what happens, whatever the features are there, it is going to be generated inside the DesignModeler. And once I have successfully imported this object, a solid object, I'm going to go to the view tab, view tool, and I'm going to select the frozen body transparency to off, so that I can see this as a solid body. Now likewise, you can select the number of types of files that can be imported into this DesignModeler. When coming to ANSYS APDL, you cannot have this much of flexibility, but coming to DesignModeler, you can import any type of CAD geometry from any kind of CAD system into this with a very less amount of loss of data. So once you have imported this one, now what I'm going to do is I'm going to go to the tools option. In the tools option, there is one thing known as a mid surface option. So I'm going to select the mid surface option, and once you select the mid surface option, what you need to do is you need to select pairs of planar faces of a solid body, so that a plane will be created at the middle of these two surfaces. So for example, see, if I select this surface and by pressing Ctrl and select this surface, what happens, this mid plane option will be creating a plane at exactly the center between these two faces. And now what I'm going to do is I'm going to select this face as well as this face also, and I'm going to select this face as well as this face, and I'm going to say apply. So once I press apply, I can see the face pairs. So if I'm satisfied with whatever the face pairs I have selected, then I can just go to the mid surface option, and I'm going to right click and say generate. See, now what happened, we have turned the solid body into a 2D object. So what is the main advantage is If we are able to convert such type of simple geometries which have a lot of plane faces into these surfaces or 2D object, the computation time as well as the computational resources requirements, computational cost, everything will be reduced and the project can be delivered in advance. So this is how we can use geometric modeler. And remember, learning geometric modeler itself is a very big course. I cannot teach you every option that is present inside DesignModeler, but using these basic options you can wonderfully perform a lot of geometric operations that you will be needing right now. Then in the next section I'm going to introduce you to the basics of static structural analysis, and then we are going to perform different simulations on 3D objects, 2D objects as well as the 1D objects using ANSYS Workbench. Thank you.